Okay, let's dive right into a work example showing how to solve this problem. Go ahead and pause the video and work this out for yourself to see if you can figure out what the answer is. So here's the answer, 4. If you got this right, feel free to skip the rest of the video. Otherwise, we'll explain exactly how we got this. If you're not sure how to do this one thing you can do is just continue guessing and checking on your calculator until you find something that works. You definitely don't want to solve it by hand every time. I'll say that because that can obviously take a while each time if you're going to guess and check, especially. But with a calculator, you can evaluate them pretty quickly. So it's actually not that bad to change the number, check, change the number, check, change the number, check. And just by process of kind of trial and error, you can eventually stumble on the right answer. So with Desmos, I can basically simulate this with a slider. If k is 1, I get apparently 4 is the output. If I make k less, okay, that goes further away. Remember, I'm trying to get to 16, so if I make k less, I seem to be getting further away from that. But if I make k more, I'm getting closer, 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 really close. And apparently I overshot a little bit. Apparently k equals 4 causes it to work. And you can verify that by hand. If you actually plug in k equals 4 here and then evaluate that integral between -2 and 2, you should get 16. And that's what they're asking for. So that's why k equals 4. Now, you probably already realize that's not how they want you to solve this problem. The way they want you to solve this is by using certain integral properties. And honestly, this is really just a backwards version of something you already know how to do. There's really just one thing that's a little unusual about it, and that's that we don't know what k is. However, even though we don't know what k is, we do know that k is a constant. And it turns out that's all we need to know to be able to integrate it. So what do we mean by this? Well, if k is a constant, think about this. If you had over here, if you had k, yeah, if you just had, if you just had the integral, let me do it like this. If you just had the integral of k with respect to x, and again, think about k. K is a constant, so it could be like 2, 3, 4, who cares? What is the integral of 2? What is the integral of 4? What is the integral of 5? Well, it would just be whatever the number is, 2, 3, or 2, 4, 5, times x. So what's the integral of k in general? Kx. And you could often say plus c, but we don't really need that because we're dealing with a definite integral. And just to check this, again, think about it. Like, convince yourself that this would be true if k was 2. The integral of 2 is 2x. If k was 3, the integral of 3 is 3x, etc. That logic applies no matter what k is. And we can use that logic over here. So if we're trying to find the integral between -2 and 2 of this, we can literally just find the antiderivative of this expression. For the first one, we can just use the power rule, so that'll be 1/8 times x to the 8. Sorry, x to the 8th. Plus, kind of what we're talking about over here, kx. And we still need to evaluate it between -2 and 2 for the definite integral. And what they're telling us is that whatever that is, whatever this right or left side of the equation is, what we have written here, that whole thing equals 16. So if we just solve this for 16, or solve this and set it equal to 16, we should have an equation with k in it, and then we can basically isolate k and solve for k by reverse engineering. So let's do that. So how would this work? Remember, if we use the second fundamental theorem of calculus, we basically plug in certain values. So it'll be 1/8 times 2 to the 8th plus k times 2. That's kind of the first one, or the first half when we're evaluating at the upper bound. And then we subtract basically the lower bound. So minus 1/8. And what will this be? This will be -2 to the 8th plus k times -2. And that whole thing equals 16. So there you go. And then we can continue to work this out. So 2 to the 8th. Here's a one useful trick you can do at least. Well, there's a couple of things you could do that's useful to simplify. But one thing you can do, you see that you have 1/8, and then you have basically minus 1/8 of -2. Well, what's -2 to the 8th? You can look at it as, oh, it's just +2 to the 8th. And then and again, I'm going to do a couple of steps at once, but if I simplify all these and like distribute the negative sign, actually, let me do it. Let me break it apart separately just because I think that'll make it easier. So if we have 2 to the 8th plus 2k, and then distribute the negative sign, minus 1/8. What is -2 to the 8th? It's also +2 to the 8th, because you can, any if you have any negative number raised to an even power, it's a positive number. So that's why we can drop that algebraically. And then distributing that in, that's going to be plus 2k again. And then again, you could evaluate this if you want. So like 2 to the 8th, you could look at it 8 as 2 to the 3rd if you want. And then you can take advantage of exponent properties. 2 to the 8th over 2 to the 3rd would be 2 to the 5th. That makes it a little bit easier, slightly smaller numbers to work with. 2 to the 5th is 32. But you don't even have to do that if you notice that these are literally the same thing. So they just cancel out. And then you have 2k plus 2k is 4k, combined like terms equals 16. And then hopefully it makes sense from there that k, like we said, k equals 4. So there you go. That's how you figure this one out. It's really the same thing that you're used to. It's really just one insight you need at the beginning, that even though you don't know what k is, you can still integrate it if you know something about it, namely that it is a constant. And this would apply even more generally too. Like if you wanted to do something like this, oops, if you wanted to do something like k equals, well, let's say this. Let's say you just wanted to integrate k x squared. You could do that too, even though you don't know what k is. It's just going to be k times x cubed over 3. We still don't know what k is, but we do know that this has to be the antiderivative, and then you can do plus c if you wanted as well. But hopefully that makes sense. So overall, that's how you work this problem. Hope it makes sense, and I will catch you next time. See ya.